going to talk about our last factoring method, which is the sum and difference of perfect cubes. The first thing that I want to point out to you is that we can factor when two values are added together or two values are subtracted together. And that's different from the difference between two squares. The difference between two squares means we can only do that kind of factoring with subtraction. With cubes, we can do it either addition or subtraction. And again, it is called the sum and difference of perfect cubes. We also use this method when there are two terms, and we need to have two perfect cubes in order to use this method, along with the fact that we should watch out for greatest common factor if it should happen to pop up. But let's take a look at what the perfect cubes are. Well, 1 cubed is 1 times 1 times 1. 1 times 1 times 1 is 1. 1 is the perfect cube. 2 cubed is 2 times 2 times 2. 2 times 2 times 2 is 8. 8 is the perfect cube. 3 cubed is 3 times 3 times 3, which is 27. 27 is the perfect cube. 4 cubed is 4 times 4 times 4, which is 64. 64 is the perfect cube. 5 cubed is 5 times 5 times 5, which is 125. 125 is the perfect cube. The cubed button on the graphing calculator, I usually use this caret, which is 1, 2, 3, 4, 5, the 6th button up from the bottom on the right of the screen. 6 caret 3, 6 cubed, is 216. If you have an out-of-date calculator, it will show the caret symbol, but it'll still give you the 216. 6 cubed is 6 times 6 times 6, which is 216. 7 cubed is 7 times 7 times 7. 7 cubed on the calculator, 7 caret 3, gives us 343. 343 is the perfect cube. You get the picture here as we get close to finishing these. 8 times 8 times 8 is what 8 cubed means. And 8 cubed on the calculator gives us the value of 512. 512 is the perfect cube. 9 cubed is 9 times 9 times 9. And 9 cubed is 729. And 10 cubed is 10 times 10 times 10, which is 1,000. And I'll show you on the calculator. 10 cubed and then we get to 1,000. One question that I should have asked is, does it make a difference whether we have a positive or a negative? And let's try it. Let's try it with the 10. If we cube negative 10, does it make a difference? And it does. So difference between two squares doesn't change, but cubed, it does. Anyway, there is a pattern. Like we saw in our difference of squares, there's a pattern here for the cube. And what the pattern is this. It's A plus B times A squared, the quantity of A squared, minus AB plus b cubed. Sorry, b squared, b squared. But I'm not a fan of memorizing. So I'd like to show you where these values came from. I'll show them in the a cubed minus b cubed. But the values come from the same place. So if you like to memorize, then you can memorize the patterns. But I'd like to show you how to do these without memorizing. And first of all, when we're working with factoring a cube, again, we can factor cube when we have two values added together, or two values that are subtracted together. And we make a little parentheses and a big parentheses. And what we do to figure out the little parentheses is we take the cubed root of a cubed. And a cubed and the cubed root are inverse operations. And we get a. I'm going to ignore the signs for a couple minutes. The cubed root of b cubed is b. Again, b cubed and the cubed root, those are inverse operations. To figure out the next value, to figure out what goes in our next position, we're going to take the a cubed, which was originally from the problem, and we're going to divide it by what we put down first in our parentheses of a. Well, a cubed divided by a. We had 3 a's. We took out 1. We have 2. Over here in the very last position, to the far right on the screen, let's take b cubed, which is the value from the problem, divide it by what was in our first parentheses, that second value, which is the b. We had 3 b's, we took out 1, we have 2. To figure out what goes in the middle, we take whatever's the first value in the first parentheses, in the little parentheses, and we multiply it by the second value in the little parentheses. So a times b is ab. And lastly, we can put in the signs. And there's a little memory technique called SOAP. And S is same sign. We started with a minus. We're going to have a minus. Same sign. The next sign in our problem here is going to be the opposite of whatever you wrote down first. So same, opposite sign, and then the AP, always positive. This value here is always positive. And if you take a closer look, what you see here is that almost everything is the same. The only difference is our signs from the a cubed plus b cubed to the a cubed minus b cubed. And again, if you like to memorize, feel free to memorize. I like to approach it from a not memorized perspective. It depends on the math teacher that you talk to. But let's look at a couple of examples here to apply this. And I want to talk about the graphing calculator within this as well. Factor completely. Don't forget that we might have a greatest common factor that we need to take out. In this first problem, we don't. But if we write this one down here, one of the ways that I know that this is a factoring cube problem is there's an x to the 3. And that exponent of the 3 at least makes me suspicious. The other reason is, if we look back at our chart, do we see 125 up here? And we do. So we've got two reasons for it to be a factoring cube. And if you can on your paper, write the little parentheses underneath the problem and then put the big parentheses beside it. And now what we want to do is we want to take the cubed root of x cubed. And we saw that with the a cubed and b cubed. Cube rooting and cubing are inverse operations. So the cubed root of x cubed is x. Well, the nice thing is, on your paper, you can see what's the cube root of 125. We look up, it's kind of in the pinkish purple color. That links back to the 5. But what if you're taking a quiz and you don't remember what it is? By the way, again, the cube root of 125 is 5. Well, what we could do is we can use our graphing calculator. And what we do with our graphing calculator, and this is a note that you might want to write down on your paper momentarily, I'll write it down. But to get the cubed root button on most calculators is you go to Math, in function number 4, so the cubed root, and then we can type in the 125 and enter. There's that value of 5. Again, Math, number 4, that function, you can arrow down to it, you can type in the number 4, and then enter will give you the cubed root button on your calculator. So now we know how to use our calculator. Let's finish this problem. What we need to do for our first term is we're going to take x cubed and x, and depending on how you wrote it on your paper, on my screen here, they're lined up. I'm going to try to erase this here. Hesitant. I'm going to take these values right there. And what I'm going to do is I'm going to divide them. X cubed divided by x. We had 3 x's. We took out 1. We have 2. Well, not only can we do that with the x's, we can also do that with this. 125 divided by 5. That's going to go over here in the last position. 125 divided by 5, if you don't know what it is, you pull out your calculator. 125 divided by 5 is just 25. The other value in our big parentheses is determined by taking that little parentheses and multiplying the 2 values together. Well, our 2 values in our little parentheses are x and they're 5. And typically we like to write the number first. So we're going to put 5x in our parentheses. And lastly, we're going to go back and put the signs in. So it's jumbled up a little bit, and I don't know if I can get rid of that blue at all. Not very well, but a little bit better here. And here comes the signs. Same sign. So we were given a plus, so we're going to have a plus. O, opposite. Opposite signs. AP, always positive. What I'm saying is I'm using this memory technique of so. S for same. O for opposite. AP, always positive. So there's the first one where we've really seen it. Let's take a look at another. And the same idea. Again, let me stress, with cubes, we can add 2 values together, or we can subtract 2 values together. We can do them both. Difference of squares Difference means answer to a subtraction problem. We can only do subtraction. But once again, we have x to the 3. That indicates that we're working with the cube. If you look up on your chart, is 216 up there? And it is. So a little parentheses, I'm going to recommend that you write it right underneath the problem. And then the big parentheses, we're going to take the cubed root of x cubed. The cubed root of x cubed is x. I know you can see it on your paper, but I just want to practice it on the computer, on the calculator as well. Math, function 4, and the 216, enter. Gives us 6. To figure out the big parentheses, we're going to take x cubed, which is our original problem, divided by x. What we've already put in our parentheses. We had 3 x's, we took out 1, we get 2. Way over here, we're going to take the 216, which is our problem, divided by what we wrote down in our first parentheses, in our little parentheses. We're going to take 216 divided by 6. 216 divided by 6 gives us 36. The middle value in our big parentheses is determined from the little parentheses. X times 6. Again, we like to have the number written first. 6x then. And finish by putting in the signs. Same sign. It was minus, so we're going to start with minus. Same sign. Then go to our next sign. Opposite sign. Always positive. Number 3. 64x cubed plus 27y cubed. So now we've got 2 different numbers. But if you look up on your paper, we see 64 up there. And we also see 27 up there. So we can start by making our little parentheses. Again, I'm going to suggest that you write right underneath the problem. And then the big parentheses. And let's look at our calculators for the cube root of 64, which is done with math, number 4, and 64. Enter. Also math, number 4, and 27, our other number. And there we have the cubed roots of both of those. So the cubed root of 64 is 4. The cubed root of x cubed is x. The cubed root of 27 is 3. The cubed root of y cubed is y. So maybe it's a little bit more challenging because now we have numbers and variables in the problem. But the process is still the same. We're going to take 64x cubed, which is the problem, divided by our first value in our little parentheses of 4x. And 64 divided by 4 is 16. X cubed is 3 x's. We divide by x. Take out 1, we're left with 2. To the far right, we can take our problem, which was 27y cubed. We're going to divide it by the second value in our little parentheses of 3y. And 27 divided by 3 is 9. Y cubed divided by y. We had 3 y's, we took out 1, we have 2. Our middle value, for the middle value, we're going to take 4x times 3y. Take each of the values in the beginning parentheses, the first parentheses, the little parentheses, multiply the numbers together. 4 times 3 is 12. X, y. We like to write the number first. And then to finish this, we're going to put in the signs. That's where SOAP comes into play. Same sign. Opposite signs. Always positive. So to finish, when we're looking at a factoring problem, we should always be looking for greatest common factor first. And right now is really the first time that I've brought it up. But really, for every single problem, factoring problem that we do, there's always a chance that there could be a greatest common factor, as there is in this particular problem. One of the hints of that is, if you look above at your chart, there's no 5 up there, nor is there 40 up there. But the biggest number that divides into both 5 and 40 is 5. So let's start by factoring out of 5. 5x cubed divided by 5 is x cubed. 40 divided by 5 is 8. And now we have a value. Now we have a parentheses that's a perfect cube that we can factor. I'm going to write the little parentheses as close to right underneath the x cubed minus 8 as possible. And the cubed root of x cubed is x. The cubed root of 8. Again, math, number 4, and then type in the 8 and enter. The cubed root of 8 is 2. To figure out what goes in the big parentheses, we're going to take x cubed divided by x. Don't go back to the very beginning. Go back to after you took out the greatest common factor. So it's x cubed divided by x. We had 3 x's, we took out 1, we get 2. At the end, we're going to take 8 divided by 2. Well, 8 divided by 2 is 4. And what's going to go in the middle of our big parentheses is coming from our little parentheses, which is x times 2. We like to write the number first, so this is going to be 2x. And then we can finish by putting in our signs. Same sign. Opposite sign. Always positive. And now we factor. As you start to think about your practice, one thing to point out, you don't have to multiply these back together. If you multiplied this all back together, you would end up with 5x cubed minus 40. And it would be a lot of work to get to that point. Our goal as you work through these notes and through the practice is to factor, not to multiply.